Yes friends, today we are going to discuss bubble sort. As you are knowing that in previous topic we have discussed selection sort, right? Bubble sort is more popular. Most of the places they are using bubble sort technique for the sorting of the elements, whether you are going to sort in increasing order or decreasing order. But by default, when person used to say sorting, it means what? Increasing order, right? So let us see that in bubble sort how we are going to solve the examples and how to write the algorithm for bubble sort and how to find out the time complexity of bubble sort algorithms. So we are going to discuss first example, right, algorithms and time complexity for the bubble sort. So remember that if we are talking about bubble sort, it means what? We will be having set of elements, right, set of integers, right? We have to sort in ascending order. It means what? We are need to compare one element with other elements, right? So name of the algorithm is bubble sort. It means bubbling, right? We are going to find out the largest element by comparing the elements one after others, right? And at last largest element will be shifting towards rightmost place, or you can say that last place, right? So one element will be compared with second. Whatever the elements are larger, right? If first element is larger than second, we are going to swap it. Similarly, after swapping, we are going to compare second and third element. If second element is larger, we are going to swap, right? It means larger element will bubble it and will go to the last positions. And that you have to repeat it again and again for depends on the number of iterations required for given examples. Say as for example, here we have a number of element is 5. So 5 elements we are going to read it for the arrays, right? 16, 12, 18, 4, 10. These 0, 1, 2, 3, 4 is a index. These all are the index, right? Sorry. This 10, 4, these all are numbers. So first number is 16, 12, 18, 4, 10. These all are not in ascending order, right? So we are going to apply the bubble sort. How will apply the bubble sort? We will go with the first iterations. These j is equal to 0, 1, 2, 3 is number of iterations required to perform the task. So once you are going to compare 16 and 12, right? 16 and 12, which is greater, first value is greater. If first value is greater, when you are writing the number in ascending order, say 5, 10, 15, 20 in ascending order, we can see that next element is greater than the previous element, right? So definitely we need to swap it, and 12 will go to the first positions and 16 will go to the second positions, right? Similarly, in next iterations, right, for next values, 16 and 18 we are going to compare. 16 and 18, you will see that, right, 16 is lesser than 18. Swapping is needed? No. We are not going to exchange the values because 18 is larger than 16. Then next we are going to compare with 18 and 4, right? 18 and 4. So here you can see that 18 is greater than 4. So 4 has to go to the previous place and 18 has to go to the very next positions. So we have swapped it, 4 and 18. Similarly, now we are going to compare 18 and 10. So 18 is greater than 10, we are going to swap it. So after swapping, we are able to see that 18 is the largest element among this given input, and 18 bubble out and went to the last position of the arrays, right? So once we done with the first iterations, then first element, this all called first one iteration, okay? So one iteration is completed, then one element, or that is largest element, will be shifted to the last positions, right? As in 5, 10, 15, 20, largest element is 20, it will go to the last position. So 18 came to the last positions. Similarly, what will happen? Now rest of the elements we are having 12, 16, 4, 10, right? Sorry. So this 12, 16, 4, 10, again it is not in ascending order, right? So next we are going to compare 12 and 16. If you are going to compare 12 and 16, there is no change. no change because 16 is greater than 12. Now we are going to compare 16 and 4. 16 and 4. First to compare this, there is no change. Now you are going to compare 16 and 4. Since 16 is greater than 4, we are going to swap it, right? So after swapping 4, 16. Now next 16 and 10 you are going to swap, right? We are going to check 16 is greater than 10, hence we can swap it, right? After swapping we can find this particular element 16 came to the second last position. 18 was already sorted in the previous iterations. Next iterations, one more element we got it, that is second largest element of the list went to the second last positions. Similarly, next iterations what will happen? Next iterations, again we are going to compare 12 and 4. Since 4 is lesser than 12, we are going to swap it, right? Next 12 and 10. 12 and 10, 12 is greater than 10, we are going to swap it. So after swapping it, we can see that 12 is the next largest element. So it is came in the right position, that is called array of 2. So 18, 16, 12. Now in the last iterations we have 4 and 10. We are going to compare 4 and 10. Since 4 is lesser than 10, no need of swapping it. It means 10 is already sorted. So in that case, we can see that this particular set of elements is in ascending order. An element is already sorted. Now, how to write this program? How to write this program? What I said you friend, first you are going to do, for n is equal to 5, you are going to read 5 elements. If you are going to read the 5 elements, we need array. So for that reason, you have to write a program to read 5 elements. Int n, ij, temp, these are all the variable declarations. Enter the number of element, n is n. So here n is equal to 5 we have given in examples. Now enter the element to be sort, right? So we are going to enter one by one all how many elements? 5 elements, right? For that, we are going to write one for loop for I is equal to 0, I less than n. Don't write it here equal to, because I is equal to 0, started with 0, so I less than n, I plus plus. And we are read array, name is a of I. So all those 5 elements we have read it. And we wanted to print what are the elements we have read it. We wanted to print what are the elements we have read it. So it is 16, 12, 18, 4, 10. We read with that input by using a scan of statements, and we have printed what are the elements we have read. Now main part will start. What is main part? Here I is equal to 0, I less than n minus 1, I plus plus. This is number of passes, number of iterations. Next loop is j is equal to 0, j less than n minus 1 minus I, j plus plus is to compare the number of elements. Basically most of the work we are going to do it with these values. If a of j greater than a of j plus 1, if previous value is greater than the next values, we need swapping. So we are going to swap. If previous value is not greater than the next element, no need of swapping. Okay, it will go simply in the next iterations. So let us see that. If you have values 10, 5, 2, 7, right? I say we are having 3, 10, 3, 10, 5, 2, 7. We need to apply. So we have read n is equal to 5. We need to apply this bubble sort. So if our index 0, 1, 2, 3, 4, right? Less than 4. So I is equal to 0. Now why I less than n minus 1? N minus 1 is 5 minus 1. 5 minus 1 is 4. I less than n minus 1 means less than 4. Means I pointer will come till here. I pointer will go till 3 only. Right? So let us see that I is equal to 0. First iteration we are going to perform the task. What are we going to perform? J will start from 0. J will go till n minus 1 minus I. N minus 1 minus I is 0. So n minus 1 minus 0. N minus 1 remain n minus 1. Right? So j will also go till these positions only, j is equal to 3. So let us see that. First, a of 3, we are going to compare 3 plus 1, right? So for I is equal to 0, j is equal to 0, right? So a of 0 is 3, a of j plus 1, 0 plus 1 is 1. We are going to compare. Is 3 is greater than 10? Is 3 is greater than 10? Is 3 is greater than 10? No, it is false. If it is false, no need of swapping it. If no need of swapping means what? J pointer will increase. J was 0, j becomes 1. For j is equal to 1, a of 1 is 10 greater than a of j 1 plus 1 is 2, 5. Is 10 is greater than 5? Yes, true. If it is true, then what will happen? We are going to swap. How? By using temp. Temp is equal to a of j. A of j is a of 1. So we are writing here temp is equal to 10. A of j is nothing but 1 is equal to a of 1 plus 1, 2. Then a of 1 plus 1 is 2 is equal to temp. And what is the value of temp here now? 10. So now you can see that now value becomes 3 was at their place, at the a of 1 becomes 5, and a of 2 becomes 10, and a of 3 is 2 and 7. You can see that this value got changed now, right? Similarly, now 3, 10, 5, 10, j, next iteration j is 1, j becomes 2. If j is 2, is 5. Is 5 is greater than 2? Is 5 is greater than 2? Yes, it is true. If it is true, then we need to swap it. If we need to swap 2 and it will come 5. Similar things we have discussed over here. For I is equal to 0, less than 4. For j is equal to 0, we are going to compare 12 and 16, right? So 16 is greater than 12, condition is true, we are going to swap it. Then after j is equal to 0 over j is equal to 1. J is equal to 1, we are going to compare a of j plus 1, 16 and 18. So is 16 is greater than 18? No, it is false. So no need of swapping this 16 and 18. So now j is equal to 2. So j is equal to 2, we are going to compare, right? Next element 18 and 4. So we can see that 18 and 4, 18 is greater than 4, 18 is greater than 4, we are going to swap it. So we are going to swap, and after swapping, where our value is a of 2 is 4, a of 2 is 4 and a of 3 is 18. Similarly, j is equal to 3. Till here condition is true. J is equal to 3. We are going to compare a of j plus 1. We are going to compare these elements 18 and 10. Once we are going to compare 18 and 10, it will go swapping as a of 3 is 10 and a of 4 is 18. So finally 18 will come out as the largest element. These things we are going to repeat as I said you earlier for each and every iterations. And finally we will get sorted elements. Right? So here you can see that 3, 5, 10, 2, 7 you got it. Next iterations what will happen? We are going to swap this 10 and 2. So finally answers will be looks like 3, 10, 3, 5, 10 to 7. Right? 0, 1, 2, 3, 4. So we are going to check a of 10. Now we are talking about j is 2. If j is 2, then j plus 1 is 2 plus 1, 3. Is 10 is greater than 2? Yes, it is true. If it is true, we have to swap it. After swapping, what will happen? 2 will come to A of 2 positions. So we'll get 3, 5, 2, 10 because this element is swapped now, right? Because this condition is true. Similarly, J becomes now 3. So this is 3 and 4. So J plus 1 becomes 4. Now you're going to check that whether 10 is greater than 7. Yes, condition is true. If it is, then you're going to swap. Right? So 10 came to the last positions. Now what will happen? J is equal to 4. If J is equal to 4, then condition is failed. Right? In algorithms you have written that condition if J is less than n minus 1 minus 4. So 4 is not less than 4. 4 is not less than 4. Hence condition is false. Hence these all iterations was for I is equal to 0. I is equal to 0. So I is equal to 0 is done. Now next iterations will start for I is equal to 1. Once again you started with I is equal to 1, J will start from 0. For I is equal to 1 again, J will start from 0 and this part we have to do it. Only difference is here at the place of J, what will happen? J is less than n is 5 minus 1 and since I is 1, 1. So 5 minus 2 is 3. So J less than 3 means J pointer will go till second positions only. J 0, 1, 2. Right? So say here J is 0. First I want to compare, is 3 is greater than 5? No. So no change. Okay. 3 is not greater than 5. So no change. So J will increase. Now J becomes 1. So is 5 is greater than 2? 5 is greater than 2? Yes. True. If it is true, we need to swap it. Right? 5 will go to the next position. So after swapping, what will happen? 3, 2, 5. It's got swapped. A 7 is there on positions. Right? Next what will happen? J increases, J becomes 2. If J becomes 2, right? J becomes 2, then 0, 1, 2. This is the position of 2. Is 5 is greater than 7? Is 5 is greater than 7? No, it is false. If it is false, it will be remain same. Right? It is remain same. J is equal to 3, condition fail. It means what? 7 is already there at the right positions and this part is already sorted. 7 and 10 is sorted. So next what will happen? Next iterations will be taking 3, 2, 5. 7 and 10 is already been sorted. So 0, 1, 2. Again I value will increase because first iteration done, this second iterations. Now I is equal to 2. Once I is equal to 2, again J will start with 0. J started with 0. So we are going to say that 3, A of J 0, A of J plus 1, 0 plus 1 is 1. Is 3 is greater than 2? 3 is greater than 2? Yes, condition is true. In that case, we are going to write 2, 3, 5, 7, 10. Now J increases, J becomes 1 at these positions. So now we are going to compare A of 1, A of J 3 and J plus 1, 1 plus 1, 2. Is 3 is greater than 5? No, false. False. So no need of swapping it. Right? Next what will happen? J is equal to 2, condition fail because 2 is not less than 2. As per the given conditions, 2 is not less than 2. Hence what will happen? Now, whatever the elements we are having it, we will consider this. Last 3 element is already sorted. Now we have 2 elements and I iteration is I is equal to 2 done, I is equal to 3. Right? J will start from 0. A of 0 is 2, A of 1 is 3. Is 2 is greater than 3? No, false. Hence, J will increase. J is 1 and that we need no need of checking it because conditions becomes false because I is 3. If I is 3 friend, what you are supposed to do, n minus 1 minus 3, n minus 4, 5 minus 4 is 5 minus 4 is 1, and j position you are adding 1. 1 is not less than 1. 1 is not less than 1 is condition fail. It means these values 2, 3, 5, 7, 10 is already in sorted order. So this is happened by using bubble sort. As I said you that in bubble sort we are going to find out based on the comparisons, largest element will go towards right hand side last positions. Similarly, second largest elements after getting swapped again and again, it will reach to the second last positions, right? And similarly, we are going to repeat all these iterations. At the end, all the elements will be in ascending order. Now, to discuss the time complexity of binary search. Remember that, friend, as we have discussed time complexity of non-recursive algorithms. This is non-recursive algorithms. Hence, you are having some looping statements as well, right? And we are having nested for loop. As I said you that this is the main part of our bubble sort, right? So, in bubble sort, to find the time complexity, we need to recall time complexity, how to find out the time complexity for non-recursive algorithms. So first we are going to find out what are the basic operations in this and how many times this basic operation is repeating. So what is the basic operation in these algorithms? I would probably, you already identified what is the basic operations is comparisons. So this is the basic operations. How many times you are going to repeat this depends on these loops. And which kind of loop it is? Nested for loop. So first loop is I is equal to 0 to n minus 1. I less than n minus 1. It means it will go maximum of n minus 2. Please concentrate. I is equal to 0. I less than n minus 1. It means what? True value of I is up to n minus 2. So we are going to write time complexity. So as a since there is a two loop, nested loop, I is equal to 0, I is equal to 0 to n minus 2, j is equal to 0 to, you can check n minus 1 minus I, again it is less, so n minus I minus 1 minus 1. N minus I minus 2, and basic operation is what? As I said you, comparison, right? So we are writing here 1. So these many times basic operations are repeating, and we have already seen it, right? Same operations are going to repeat again and again. Which loop you are going to solve first? Innermost loop. How to solve it? We are going to write I is equal to 0, n minus 2. No, j is equal to 0 to n minus 2. Upper limit minus lower limit plus 1. We have discussed in non-recursive algorithms, upper limit minus lower limit plus 1. So how to do that? N minus I minus 2, upper limit minus lower limit is 0 plus 1. We can simplify this. Once we will simplify it, I is equal to 0 to n minus 2, here minus 2 plus 1, so minus 1, n minus I minus 1. Now we come to outer for loop. Now what you are supposed to do, friend, you just put value of I in this one by one up to n minus 2. So if first value of 0, if you will apply 0 here, so n minus 1. If you will apply I is equal to 1, it becomes n minus 2 plus. It will go till, if you will apply n minus 2, n minus n minus 2 becomes 2 minus 1 is 1. You just check that. If you apply here n minus 2, n minus I minus 1. At the place of I, if you are going to apply n minus 2, what is the values? Sorry, it is minus 1. What is the values? N minus plus 2 minus 1. Hence, overall values is going to be 1. So, you have written 1. So, now you can write it, time complexity. Can we write this in a reverse order? Yes. This is nothing but 1 plus 2 plus 3 up to n minus 1. This is the time complexity, right? By seeing this expression 1 plus 2 plus 3 up to n minus 1, we can recall sum of n natural number. And what is the value of n here? N minus 1. And what is the formula of sum of n natural number? N into n plus 1 divided by 2. So, n is nothing but n minus 1 into n minus 1, n into n minus 1 plus 1 divided by 2. So, this 1 minus 1 got cancelled. So, what is the time complexity here? N into n plus 1 divided by 2. N into n minus 1 divided by 2. Right? So, these many comparisons is required in the bubble sort. Right? If you are going to denote this by using asymptotic notations, then you can see that n into n minus 1 by 2, if you multiply it becomes n square. Okay, and it is quadratic equations. N square by 2 is a constant, and we have seen that n into n minus 1 divided by 2 is a quadratic equations, and in that case we can say that t of n, this value is less than or equal to n square by 2. Hence, we can say that time complexity of Tn is equal to theta of n square. We have discussed in the asymptotic notations as well, n into n minus 1 divided by 2 is lie between n square by 4 to n square by 2. Right? So, this is the time complexity of bubble sort. Again, for conclusion, summary, in bubble sort, as I said you that it is a very popular algorithm to sort the elements in ascending order or descending order. It works for the integer values, numbers, or even you can perform the task for the strings, right? A string, in the case of strings, it will go by using their ASCII values. Comparisons will happen based on their ASCII values, and we can sort the given names in ascending order based on same concept, right? We'll meet you in the next class. Thank you.